1998, M.Tech in Maintenance Engineering from MANIT Bhopal in 2001, and PhD degree on gear fault diagnosis with vibrational analysis from IIT Delhi in 2005. He served as lecturer at BITS Pilani, Goa campus during 2005-06, postdoctoral fellow at University of Alberta, Canada during 2006-07, and he was manager in Crompton Greaves, Mumbai, and Larsen & Toubro, Mumbai in between 2007-09. Then he joined IIT Indore in August 2009, and currently he is working as professor in IIT Indore. His research interests are in the areas of mechanical system, signal processing, gear fault diagnosis, noise and vibration isolation, and conditioning monitoring. He has published more than 50 research articles in reputed international journals. He has produced 6 PhD students and currently guiding 5 research scholars. At present, Sir has sponsored projects worth rupees 150 lakhs, and he has done many industrial and government consultancies and testing work in the field of condition monitoring, signal processing, and mechanical systems, and noise and vibrations. We welcome you, sir, that you took your precious time, and I kindly invite you to the podium to enlighten us with your knowledge. Thank you.
It's a nice introduction, and I'm really honored to be here and give my talk on some of the research area on which I am working. So as he already mentioned, like my research area is on condition monitoring, and that is, I think, the main objective. Okay, but you should also be aware, like the material which you have developed, or any material which you have characterized. Okay, what will be the end use of that particular material? Okay, so if you know, like, this is going to be used in this particular application, so other than mechanical properties, you need to evaluate some other properties also. So considering that, I'm connecting this talk with this theme of this conference. Okay, so like if you talk about steel, so there are n number of applications. So definitely gears are one of the application. So if you see gearboxes and gears in particular, so they are made from steel. Okay, so a lot of work has been done about what will be the, basically, I mean, when you are designing anything, so either you design it for strength or for reliability is one of the thing which is very important. Okay, so lot own application, but now lot of characterization has been done for polymers. But if you are using polymers as a gear, okay, so noise, what will be the noise level? Generally, it is thought that when you are using polymer gears, then noise is very less as compared to the metallic gears. Okay, so that is obvious, but still, if you are using polymers for gear application, so how you can, whether it is acceptable or not, that has to be basically characterized. So I will be considering the noise and vibration aspect. So that is one thing, and as the topic suggests, condition monitoring. So I don't know whether you are aware of this topic or not. So I will briefly describe about what is condition monitoring, and then how polymer gears, you can do the condition monitoring of polymer gears, and ultimately you can increase the reliability of your system. Okay, so begin with what is condition monitoring. So basically it's a maintenance strategy. Okay, so whatever we do, okay, if you go in any industry, most of the time it is a maintenance. Okay, you are doing a lot of maintenance activity because once you have set up your plant, okay, so all the machines are running, be it manufacturing plant or anything. So the main task of engineers is maintenance. Okay, so one of the main activities is maintenance. So they are basically, you can, if you see, there are 3 types of maintenance. One is breakdown maintenance, then preventive maintenance, and then predictive maintenance, or condition based maintenance, or condition monitoring. So that is basically the idea of condition monitoring. I think you are aware of what is breakdown maintenance. Okay, so whenever anything is out of order, okay, if it's not functioning, then you take some corrective measures. Okay, so say for example, if you are driving a car and if tire gets punctured, so you have to replace it, okay, or repair it. So depending on the situation, either you will be replacing it or you are repairing it. So that is known as basically breakdown maintenance. Okay. Then there is a preventive maintenance where you are carrying out maintenance activities at regular intervals. So I mean, most of the time I give the example of car because all of us are having some vehicle, okay, be it car or any two-wheeler. So you take it to the workshop, or when you buy it new, or at regular intervals after 3 months or after 6 months, depending on the OEM what they prescribe, okay, that you have to take it for preventive maintenance. So irrespective of condition of the machine, okay, you are performing certain maintenance activities, okay, at regular interval. That is known as preventive maintenance. Okay, so the problem with the preventive maintenance is you are either doing over maintenance or you are doing under maintenance. Okay, because if you have to take it after 6 months, so somebody who is driving car for 5,000 kilometers every month, he has to go after 6 months, and somebody who is driving 500 kilometers per month, he has to also take the car after every 6 months. So the maintenance requirements are different, but you are supposed to perform the preventive maintenance after some regular interval. So you are doing sometimes over maintenance or under maintenance. Both are not basically justified. Okay. So the condition based maintenance is a strategy or philosophy which has come up where you have to maintain a particular system according to the condition of that particular system. Okay. So that is known as condition based maintenance. So you are supposed to assess the exact condition of the mechanical system or that machine. Okay. So this is how you do it. So basically you have to select a particular parameter and then you monitor that particular parameter over a period of time, and then you observe what is the change in the magnitude of that particular uh, parameter. Say for example, if you are doing condition monitoring of gearbox, because I will be taking case of gearbox. So suppose you are monitoring gearbox, and if you are taking vibration signal at regular interval, so and if you are plotting it, so you may get this kind of plot, you may or may not get. Suppose you get this kind of plot, so it suggests that initially, okay, wherever you see there is some ups and downs. This is the best fit curve. So here you can see, like initially there is no change in the condition of the machine, but if you observe that over a period of time that chosen parameter is increasing, it means there is some malfunction or some fault has developed in the machine. Okay, and that's why there is a growth in that chosen parameter. So it can give you some indication that machine has developed some fault. So you need to take preventive actions or corrective measures, so that you can avoid breakdown. Okay, so there is a lead time. You get some lead time where you can say that okay, uh, if you run this machine continuously under the same condition, then it will fail maybe in the next 1 week or whatever. Okay, so but how to do it? Okay, it looks very simple, but the main challenge in condition monitoring is to detect the fault as soon as possible, as early as possible. Okay, so if you can detect the fault very early, so you have sufficient lead time to plan your maintenance activity. Okay, so this is the philosophy of condition based maintenance or condition monitoring or predictive maintenance or machinery health monitoring, whatever you call it. So that is the philosophy, and how to do it. So as I mentioned that you have to select a particular parameter. So what parameter has to be selected? And if we are talking about mechanical system, so most of the time they are having rotating machines. Okay, at least one prime mover is there which is having some rotating machine, okay, and then it has connected with belts and pulleys and gears, bearings, all those things, reciprocating things. So these are the mainly major components in any mechanical system. So uh, for mechanical system, vibration is one of such parameter which is giving you a lot of information about the condition of the machine. Okay, so selection of the right parameter is very important for condition based maintenance. Okay, so there are various parameters which you can select. So I will talk about that. So basically, you can collect these parameter at some regular interval, or you can collect it on continuous basis. So that is known as online monitoring. If you are measuring the chosen parameter continuously, then it is known as online condition monitoring. Otherwise, it is offline condition monitoring. So it depends on the criticality of the machine. Okay, whether you are going to perform online or offline. Okay, so another very important thing in condition monitoring is critical machines. So you have to identify which machine is critical, because this kind of maintenance requires some some instrumentation and manpower. Okay, so if any industry is investing some money on instrumentation and manpower, then definitely uh, you cannot do it for any machine which is not that critical. Okay, so how to find out what is critical machine? So definitely like so critical machine you can basically definitely, it's terms of cost only. So if the breakdown cost is very high of any machine, then that becomes a critical machine. Or sometimes human safety is involved. Say for example, if helicopter gearbox it fails, then human life is at a risk. Okay, so in helicopter the gearbox is a very critical component. So if you are doing condition monitoring of the helicopter gearbox, then it makes sense. Okay, so that is how you will decide that this machine is critical. Then you will put some instrumentation, and then you will do the condition monitoring. So yeah, so basically condition monitoring is used to detect faults in machines and then anticipate breakdown and diagnose the problem. These are the three activities. So first you have to find out that there is some fault, okay, and how much time will it take, and then what is the root cause of that problem. Okay, so all these things if you can do, this is something which we want. Okay, like what fault has developed, what is the root cause, okay, and how much time it will take to before breakdown. So it looks very simple, but it requires a lot of knowledge to implement it. Okay, so yeah, so I was mentioning about critical machines. So definitely for successful implementation of condition monitoring, you have to find out the critical machines. Okay, once you identify in your industry or in your mechanical system that these are the critical machines or critical components, then you have to select the parameter. So as I mentioned, in mechanical system, mostly there are rotating parts and reciprocating parts. So vibration is a very good parameter. Okay, but there are various other parameters like pressure, temperature, flow rate, friction, corrosion, oil contaminant, exhaust emission, vibration, noise. So these are various things which you can you can measure, but you need not to be, essentially you have to pick one or two. Sometimes just one parameter is sufficient. Sometimes you have to you have to select two parameters at a time. So it gives you better information about the condition of that machine. Okay, so like pressure, temperature, these are also some of the parameters. So these are known as primary parameters, and some parameters are called secondary parameters. So primary parameters are those which are basically the function of a machine. Say for example, if you are having compressor, so the main function of a compressor is to increase the pressure. Okay, so if you are measuring the pressure and if you see that the required pressure has not been achieved, it means there is some malfunction in the compressor. Okay, so these are basically the performance based parameters, but they are very slow. Okay, when the fault has grown, then only they will reflect in the change in the pressure. Okay, but secondary parameters are basically the disturbing effect, okay, like vibration or the wear debris or the oil, yeah, so noise. These are the secondary thing which is not the main function of the machine, but these are the disturbing effect, but they give a very good information about the condition of the machine. As soon as the condition of the machine changes, these parameters change. Okay, so that's why secondary parameters are very important. So I mean, I was just talking about philosophy of condition monitoring. Although I don't know whether it is directly related with this top. I mean, the theme of this conference, but yeah, as far as reliability is concerned or sustainable manufacturing or whatever you call, so if you integrate all these things, then definitely your material processing and characterization will make sense. Okay, so now this is okay. So if you apply the condition monitoring, then what are the advantages? So these are the advantages, like it avoids unexpected catastrophic machine failure. Okay, because you know that some fault is developed, so you suppose in the helicopter gearbox, if you can detect it very early, then you will say, okay, now you cannot fly this because some fault has already developed. Okay, so you can save I mean money as well as life. Okay, and as compared to preventive maintenance, the number of overhauls is reduced because now you are maintaining your equipment as per the requirement, not as per the time. Okay, so in that sense, number of overhaul is reduced. Spare parts can be planned and procured in time because you know that there is a lead time. I mean, the machine will take 2 weeks to fail. So because we are doing condition monitoring of the critical machines, and for critical machines, you don't have spare parts readily available because these are quite costly machines. So you, whenever some machine fails, then only you order for those components. Okay, but here, I mean, so it takes time. So here, if you know that uh, after 3 weeks it is going to fail, then you can process your order and then you can get the parts. Okay, so in that sense, your availability is more, plant availability is more. Okay, so in all, if you apply the correct condition monitoring, then you can save a lot of money. So as I mentioned, there are various parameters which you can select for condition monitoring. So these are the parameters, and based on the parameters, there are techniques. So like visual inspection, performance monitoring, vibration monitoring, acoustic emission, noise monitoring, thermography, wear debris monitoring, oil analysis, shock pulse analysis. So these are the techniques based on the parameter you have chosen. But visual inspection is more of non-destructive testing, where you are, I mean, using some like dye penetrant to see the surface cracks. So I mean, those are basically, if you are maintaining any machine, so better you first do some visual examination. That too, visual means with using some techniques, non-destructive testings, and maybe uh, borescope, okay, or some endoscopy basically. So that kind of thing. So like if you have a heat exchanger, if you want to see if there is some scaling in the tubes, so you can use borescope. So I mean, if you talk about maintenance, first you need to assess the condition of the machine visually also. Okay, but this is as such not a condition monitoring technique, but it's always better to have complete information about the machine using some visual tools, be it endoscopy or some NDT like dye penetrant test or things like that. Okay, so then performance monitoring, as I already mentioned, that every machine is supposed to perform something. So say for example, IC engine. So if your IC engine is having some lubricating oil, definitely it has to have some lubricating oil. Okay, and if you see, if you are monitoring the lubricating oil consumption, and if all of a sudden it increases, okay, all of a sudden the consumption of lubricating oil is too much, it means the lubricating oil is going in the combustion chamber. Okay, so the performance of the engine will deteriorate, consumption of lubricating oil will increase. So you can correlate, but these are, I mean, very primitive things, and it takes, I mean, you detect the fault at the later stage, not at the early stage. So which is not good. So these two techniques are very, I mean, primitive, I can say, but sometimes they are helpful because you are not investing a lot on instrumentation. Okay. Now coming to vibration monitoring, I will be covering it, and then acoustic emission, noise monitoring. These are all related with measurement of vibration at various frequencies. Okay. So these are the techniques. Thermography, basically you are using infrared cameras to capture the thermal image of machine, and then if condition of the machine is deteriorating because of say bearing failure, some friction is, I mean, a lot of friction is there, so heat will increase. So I mean, you can have correlation between the thermal image and the condition of the machine. Okay. And then wear debris monitoring, because most of the mechanical system they have tribo elements. Okay, so there is friction, lubrication, and wear phenomena taking place. So because of wear, if you are collecting the wear particle, okay, and then if you are making I mean, there's a ferrogram, okay, and then you can see like how the wear particles are deposited, I mean, what is the size, what is the shape and morphology of those wear particles. So considering those, you can understand which part is, or the machine is getting worn out. Okay. So wear debris monitoring is another technique where you can understand or the condition of the machine. Then oil analysis is basically the measuring the oil properties like viscosity, total acid number, total base number, something like that. So that is also related with the condition of the machine. And then shock pulse analysis is another technique specifically designed for bearing fault detection. So okay, just to give you a brief of what are the various techniques which are available for condition monitoring, I have discussed here. So coming back to polymer gears, okay. So when you are using polymer for gear application, as you can see nowadays, a lot of I mean, automotive, textile, food processing, aerospace, electronics, wherever. I mean, if you see a lot of applications, okay. Okay, so if you design a polymer gear for your application and if you operate it, okay, so mostly they are designed for low torque condition, but nowadays there is advancement in polymer where you can use, I mean, where you can have very high torque applications also. But whatever is the torque, I mean, condition, over a period of time, uh, gears may develop these kind of faults. Okay, so cracking and wear and pitting, these three you will find in steel gears also or metallic gear also. But this cracking at the pitch circle, you will not observe in metallic gears, because I mean, so if the cracking starts or the wear starts or pitting or this kind of cracking, all these things will change the performance of gear. Okay. So this is basically because the heat dissipation in polymer gears is very less. So, and at pitch point, the load is coming which is maximum because only single tooth pair is in contact. So at pitch point, high heat is generated. Although overall heat generation is more as compared to steel, because in polymer gears, heat dissipation is very less. Okay, but at this particular point, heat generation is quite high. So a lot of study has been done on how the, I mean, heat uh, distribution, I mean, how the heat is distributed over a period of time if you run at different load conditions. But yeah, this is a unique fault, I can say, as compared to metallic gears, which you never find, because in metallic gears it will fail because only of the high stress condition, and that is only at the root of this tooth. Okay. So anyway, so these are the different types of faults which may develop. So now what we have done here is, I think I have time, 10 minutes time. Okay. So we have this uh, method, okay, where we will be measuring the vibration, okay, and there are two ways by which you can analyze, because once you are collecting a signal, that is one thing, then how you understand that signal, or I mean how you process it so that it becomes a useful information. So you have time domain as well as frequency domain analysis. So I'll be doing this because it's a very simple thing to collect signal, and then some statistical parameter you calculate of the collected signal, and because it gives you information about the condition of the gear. Okay, so this will be doing. So I'll just show you. So this setup was developed by one of my PhD students who worked on polymer gears. Okay, first time. Otherwise, I used to do work on metallic gears only. So here, a testing was developed where polymer gears were, I mean, installed here, and there is a motor and then like VFD controller. Not a great thing, but yes, it is basically driving this gear at various speed. Okay, and we had some arrangement here to put load. So we have one electromagnetic brake, okay, so that we can install here, which we have somehow it is not shown here. So this is the test setup, and this is the bearing housing. So here we are putting accelerometers, okay. So the accelerometers are kept over here. So which is capturing the data in X, Y, and Z direction. And these are the basically the parameters of gear. Module is, because these two things are very important, module and pressure angle, and number of teeth in one, I mean gear is 20 and sorry, pinion in 20 and gear it is 30. Face width is 20 mm. Okay, so this is, yeah, so this is what we have done. We have created pitting at pitch line, as I mentioned, because at pitch line temperature is quite high. So we created with a small drill 3 holes here and 5 holes here. Okay, and so yeah, and this is the good gear. These are nylon gears. We bought it. We did not manufacture it. So these are standard gears, and yeah. So we run this motor like this. Okay. Yeah. So I mean, using this VFD, we can control the speed. Okay. So the speed was kept 25 hertz, 30 hertz, and 35 hertz. The load was 1 Newton meter, 2 Newton meter, and 3 Newton meter, and gear is, one is healthy, one is slight pitting, and then severe pitting. Okay, then we captured the signal, vibration signal, and these are the time domain signals of these three types of gears. So you can see. Okay, so time domain, just you see, you cannot get sufficient information what is the condition of the machine. So we calculated kurtosis and RMS, and we also plotted the gear mesh, I mean FFT, which is the frequency spectrum. Okay, so when gears are rotating, then they generate a particular frequency, which is known as gear mesh frequency, which is nothing but the rotational speed of the gear and number of teeth multiplied and divided by 60, that is the gear mesh frequency. So that gives you a lot of information about the condition of the machine. So we are having gear mesh frequencies. We plotted FFT, and then we observed how the gear mesh frequency amplitude is changing. And as I already mentioned, that kurtosis and root mean square, these are very basic parameters. And for gear fault diagnosis, a lot of indicators have been, those who are doing research, they develop indicators which can tell you the condition of the gear. So, but even these are very basic basic indicators, but they give very good information about the condition of gears. So, root mean square, and which is, I think you all are aware, which is basically the energy of the signal. Okay, so because when we are capturing the signal, that is using, I mean, now it is a digital signal, so you know at what time what is the amplitude. So you have n number of samples. So using this, if you want to calculate very easily, you can calculate what is the RMS. And similarly, kurtosis, which is basically the peakedness of the signal. Okay, in a signal, how much peaky is that signal, that you can find out if you calculate this parameter. These are all statistical parameters, okay, which is, I mean, which can be understood if you just see this distribution. Okay, so as compared to the normal distribution, how much peak is there? So this value, if it is coming 3, it means anything between 2 to 3, condition of the gear is good. But if you are getting kurtosis value around 4 or 5, it means fault has developed. That's why there is some peak in the signal. Okay, so root mean square value is also very good indicator. So we plotted, I mean, for healthy, slight pitting and severe pitting at different loads, 0 Newton meter, and then yeah. So you can see here, this is the RMS value and this is the kurtosis value. So different speed, and this is at constant load, which is no load. Okay, so you can see if there is slight pitting, the value of RMS has increased as compared to healthy gear, and for severe pitting again it has increased. Okay, so it is giving you a trend. Okay, so no work has been done so far on polymer gear. So we were trying with the basic features whether they can detect the fault or not, or whether there is some trend or not. So I mean, we got very positive results that yes, if you capture the vibration signal and if there is some fault, and if you calculate simple RMS and kurtosis, uh, if the fault is increasing, the value of kurtosis and RMS is also increasing. So you can detect the fault in gearbox. Okay. So then for 1 Newton meter trend, I mean, you can see very nice trend. The fault is increasing, the value of RMS is also increasing. Here it is even better. Okay, but somewhere here it is not doing this right thing. Okay, but yes, overall we can say it is capable of detecting the faults. These now, as I mentioned, we have also already plotted FFT, which is the Fourier transform. Okay, so gear mesh frequency, what is the amplitude of gear mesh frequency? So when we plotted that, we did not get that useful information, or that trend, we could not get that trend. So the basic time domain analysis is sufficient. I think that frequency wise, the polymer gears, probably because of the damping and all, there is mesh stiffness is, I mean, that is varying randomly. Okay, that is in steel gears there is a pattern. Okay, but in polymer gears the stiffness or gear mesh stiffness is not changing with the change in the condition, that we concluded. Okay, so yeah, these are the, I already discussed about this conclusion. Now another maybe 5 minutes. Okay, so another thing is now, okay, as I mentioned, in polymer gears the main problem is heat generation. I mean, heat generation, but heat dissipation is the problem. So it becomes heated. Okay, so uh, some of the researchers, they have tried many things or many solutions they have given. So one of them is making a drill. I mean, they have drilled some hole so that heat can be dissipated. Okay, so we thought, I mean, okay, and there are papers they're suggesting that okay, once you drill this hole, so the life of the gear is increased because it is not getting heated. But then we thought, being a noise and vibration, uh, I mean, researcher, you can say, not an expert. So we thought, okay, what will be the effect of these drilled holes on noise and vibration? Because when you are designing anything, you have to think in totality. Okay, you are reducing something, but whether it is increasing something or not. So most of the time, noise and vibration people don't consider. Okay, they say, okay, life has increased, or manufacturing cost has come down. Okay, or there is ease of manufacturing, whatever. So we thought, okay, fine, we should try what will be the noise generation whether it is acceptable or not. And generally it is thought that polymer gears are very quiet, okay, they are not making much noise. But if you are doing this kind of modifications, so whether the noise is unacceptable or acceptable. And then another arrangement was that they studied some uh, steel objects, or I mean they filled it, first they drilled the hole and then they filled it with the steel uh, cylindrical objects, okay. So these are the two things. Then we studied in the same machine, okay. Yeah, here you can see the same, yeah, here the setup is same, and you can see here the magnetic brake by which we are applying the load, and this is the accelerometer. So then again same thing we did, we captured the signal. So I mean they are the various types. A means polymer pinion paired with polymer gears, polymer pinion with hole paired with polymer gear, polymer pinion with steel pin inserted, polymer pinion with steel, because sometimes polymer to polymer gears are not there, polymer to steel gear is also there. So we tested that also, okay, with hole and with steel pin inserted. So these things we tried, okay, and these are the time domain signals. And then again the same thing like RMS and kurtosis. So this we did, okay. So the conclusion is the vibration and noise level of A, B, C, D, E and F type gear pair increases with an increase in rotational speed, which is I think a general statement. Okay, when comparing the vibration and noise level of A, B and C type gear pairs, all operating conditions show that B type gear pair has maximum noise, means where the only hole was drilled, no pin was inserted, noise level was very high. So that is something we have to be careful. Okay, noise as well as vibration level, whereas A type gear has minimum, that is obvious. And when you insert pin, so it is in between A type and B type. And so yeah, so when comparing the vibration and noise level of D, E and F type gear pairs, all operating conditions show that E type gear pair has maximum noise and vibration level. When you are having polymer versus steel and having polymer gears drilled hole, that is having the maximum noise and vibration level, whereas the D type gear pair has minimum noise and vibration level. So this is D type, means polymer pinion paired with steel gear without any modifications. So this is, I mean, some attempt I mean, my PhD student had put to understand the behavior of polymer gears in presence of various modifications which has been proposed by the researchers to increase the life of the polymer gears. So we were trying to understand what are the effect on noise and vibration as well as detection of the faults. So this is all. Thank you very much.
Same thing that you use in that.
Same thing. No. In the collected signal and the, I mean, you need to understand the system first. Okay, if it operates, then what sort of signals will it? I mean, it will generate, and then you have to correlate the selected or I mean acquired signal with the fault. So in our lab, we are trying to, I mean, mimic various kinds of faults, and then collecting the signal and trying to correlate with the signal and the fault.
So have you looked
Biodegradable? No, I have not tried, but it's a good suggestion. So maybe I can try for that also.
because in the world of sustainability
Yeah.
and
As such, I don't work on materials. As I initially made this statement, I don't work on materials. But and we did not try different types of measured noise and vibration for various various polymers. But we did it in a fault diagnosis way. I mean, you can drill close to, I mean, at which circle, what diameter you are taking. Okay, so a lot of combinations are possible, but we did not try them. Yes.
so anything frequency would be
Acceleration. Okay. No, we have used accelerometer. You can measure vibration velocity, vibration displacement, or vibration acceleration. In general, you measure acceleration if anything which is running more than 10 hertz speed. Okay, so it's better to If your speed is very slow, say in the range of 1 to 5 hertz, then displacement is the right parameter. If you are working 10 to 50 hertz, velocity is the right parameter. If you are working 10 hertz and above, then frequency. No, not frequency. I'm talking about measure displacement. You can measure vibration velocity. You can measure vibration acceleration. So if you are using accelerometer, you are measuring acceleration.
Monitoring and polymer gears. Certainly, if material processing is the core, then condition monitoring is the shield that grants it longer life. Your talk was certainly deep insight in the field of polymer gears, and everyone here is benefited. We really look forward to more enlightening sessions like this in the near future. I now request Dr. B.A. Modi sir to present a memento to the sir as a token of gratitude for his valuable time.